Okay, so boys and girls, it's a pleasure to share this session with you. If we consider the yellow block as the whole, would you all tell me how much is the value of the red piece, everybody? Half. Okay, and what is the value of the blue piece?
1/3.
And what's the value of the green piece?
1/5.
Okay. Now, what's the relationship between the red piece and the green piece? How many green blocks do you need to form one red block? I'm sorry?
Oh, sorry, they said 3.
Everybody says 3. Okay, good. So we see then that one red block is equal to 3 green blocks. So we can write that, and we could say that one red block is equal to 3 green blocks. So what would 2 red blocks be? How many green blocks, boys and girls, everybody? 6 green blocks.
There we go. That's good.
Okay, how about if I jump all the way to 5 red blocks? How many green blocks would 5 red blocks be?
15.
Okay, does everyone agree that it's 15, Taylor? Okay, now the red block, instead of calling it red, we could also call the red block a half. So let's do that. We know that the red block is 1/2. And we know that the green block is how much? 1/6. So now, supposing I want to know how many 6ths are 3/2. Can you have a student come up and explain how we would do that, please?
Sure. Who wants to figure out 3/2? How would you know how many 6ths that is? Dylan, why don't you come up and give it a try? You can come talk right into this mic. So tell Dr. Borenson what you would do for that.
Okay, so who's speaking? What's your name?
His name's Dylan.
Dylan, how would you do this?
Do 3 times 2, and it will be 6.
Okay, Dylan, so I'm not following you 100%. We want to know what 3/2 are. What color is 1/2?
Did you hear his question? What color is 1/2?
Red.
We have 3 blocks. We have the yellow block, we have the blue block, and the red block, and the green block. Which color, if the yellow block is 1, which block is 1/2? Do you remember?
Which is the 1/2 block?
Red.
Okay, but the problem doesn't say 1/2. What does it say? It says 3/2. So since it says 3/2, I need 1 red, I need 2 reds, and I need 3 reds. So the question is, I want to know how many 6ths they are. What color is the 6th block? Okay, it's the green block. Okay, everybody should know very automatically that the green block is 6. So Dylan, before I call somebody else to come up, how many, how many green blocks make 1 red block, Dylan? Do you know the answer to that? How many of these fit in here?
6.
Take 6.
No.
3.
What's that?
3.
You sure?
Yes.
Okay, let me try it. 1, 2, 3. So it looks like it's 3. So Dylan, I'm going to have 3 6 here, 3 6 here, and 3 6 here. Therefore, how many 6 altogether would 3/2 be?
How many would that be? 3, 3, 3.
9.
It's going to be 9 6. Okay, Dylan, thank you very much. Thank you for being the first volunteer. It takes courage to be the first volunteer. Can we give Dylan a hand, please, everybody? Okay, we need to do another one. I would like everyone to do this at their seats, okay? This time I have 5 halves, and I want to know how many 6 they are, okay? And I want you to figure out by using your fractional blocks. I'll give you about a minute to do that, please, before we discuss it.
Done. I'm done.
Right here, you've been doing great on this for all these lessons so far. You need to write what Mr. Borenson has on the board.
Oh yeah, bingo. I'm done.
Nice.
And because I showed my work.
So how many is there?
Can I get it right? Oh, yeah. I would just do them 5 times 4. 5 times 3. I know trick 4. What?
Everyone do it. Let me see yours. I don't see yours yet. Oh, I see now. Where's yours?
This is microscopic.
Yes, I'm gonna have to use my magnifying glass.
I'm ready.
Okay, Dylan, can we have a volunteer come up, please?
Give them 1 more minute to solve, Dr. Borenson.
I know.
Good, I know. I'm
Okay.
gonna give you a minute because I don't see it proved with your pieces or written on your paper. Same thing. I cannot send you up if you don't do the work. Oh, there. That's beautiful. Show me your pieces.
Dang it.
Excellent. Okay, so ask a neighbor. That's why I had people bring it. All right, Dr. Borenson.
Okay, who's coming up this time? Somebody else?
Okay, here, you can hold it. Just hold it kind of close to your mouth and talk in a loud voice for Dr. Borenson. Just say, I'm ready.
I'm ready.
Okay, what is your name?
Jaden.
Okay, good. Jaden, how would, first of all, read the problem. What does the problem say?
Okay, Tom, did you hear what he asked you? No. Okay. Dr.
Jaden, can you read the problem?
Repeat the question.
Can you read the problem? What does the problem say? I'd like Jaden to tell me what the problem is asking.
5 halves equals something 6.
Okay, equals how many 6? Very good. Now, what does 5 halves mean?
It means you means 5 of the halves. Like
Okay,
5
good.
halves.
5 halves means 5 copies of 1 half. Now, what color is the half? Which block? If the yellow
Red.
block is a whole, the red.
Yeah.
So therefore, 5 halves mean how many of these red pieces?
5.
5 of them. Okay. I'm not going to put all 5 down right now, but I could if we need to. So we have 5 of those red pieces. Now, each red piece, now we want to know how many 6 there are. The 6th is what color?
Green.
Okay, how many green blocks are there in each red block?
3.
So how many would there be altogether if you have 5 of the red blocks?
15.
15. Taylor, how many in the class agree that the answer is 15? Would they raise their hands?
Everybody.
Does everyone agree?
Yeah. Yeah.
Let's give JD and I's hand, please. Okay, Taylor, does everyone have their workbooks closed, their fractions workbook?
Everybody has their fraction workbook open.
Yep.
No, I want it closed.
Oh, close your fraction workbook. Oh my goodness. Now they're all closed.
Okay, very good. So let's do some review of lesson 13. We already said that 3 green blocks equal 1 red block. So let's do these problems. Let's do the top one. So let's call them out, everybody together at one time. Wait till I give you the signal. 1 half is how many 6? Please think about it for a second. How many?
3.
Okay, now instead of 1 half, you have 2 halves. So it's not going to be 3 6. What's it going to be?
4
6. Now you have 3 halves. That's not going to be 6, 6. What's that going to be? 9, 6. And now when you get 4 halves, how many 6 would that be?
12.
Congratulations, students. Every time you add a half, you're adding 3 more 6. Okay, let's now look at today's lesson. Okay, I'd like someone to come up to the front of the room to read for the class. Who would like to come up? A new volunteer.
Adrian, go ahead. You can just stay right where you are and just pull that mic a little bit.
Hi,
Hi, what's your name?
Gabriel.
Say it again.
Gabriel.
Gavrian?
Yes.
Oh boy, thank goodness I got it. Okay, could you read for me what it says?
What?
Hey, are you able to try to read this for me?
Okay. Let's consider the area of this rectangle as the whole.
Okay, so this is going to be 1. Continue reading.
The blue column at the left below displays 1/4 of the whole since it
Okay, let's stop right there. Does the whole class agree that this blue column over here is 1/4 of the whole rectangle? Would everybody raise their hand if they agree that this blue is 1/4 of the whole rectangle, Taylor? Does everyone agree with that?
Yes.
Okay, please continue reading.
One of
The 2 blue boxes.
Two blue boxes, small boxes, at the right below display 2/8 of the whole, since they are 2 of 8 equal boxes.
Okay, let's stop right there. Can you explain in your own words why this showed 2/8 of the whole?
Because it shows 2 and the whole thing is 8 and there's 2 covered.
Okay, there are 2 boxes out of 8 equal boxes, so this is 2/8. Now, which is bigger, this 1/4 or these 2/8, or are they the same?
The same.
They are the same. Okay, let's continue reading, please. We see above.
That one small blue square is half of the size of the blue column. That is at 1/8 is half of 1/4.
Okay, we have to stop right there. Can you explain in your own words, how do we see that this small box is half of this column?
How do you know that?
Because there's there's 2 different squares in the 2/8.
Exactly. 2 of those squares make up the column, so each one is half of the column. Okay, continue reading to the next line, please. Hence, we need
twice as many 1/8 as the 1/4 parts to form an equivalent fraction.
Okay, let's stop right there. We need twice as many 1/8 parts as 1/4 parts. So even though the 8 is a bigger number at the denominator, we need twice as many of them to equal 1/4. Okay, let's continue reading. One more sentence. You're doing very well.
Let's consider the missing number in this equation. 3/4 equals something 8.
Okay, so this is a new problem. 3/4 are how many 8s? Continue reading.
Since the number of 1/8 parts must be double the number of 1/4 parts, and we have 3 1/4 parts, we need 6 1/8 parts.
Okay, do you agree that the answer must be 6/8?
Yeah.
Okay, can you explain in your own words why the answer must be 6/8?
3/4 is the same as 6/8.
How do you know?
Because you double the 3s to the 6, and I figured out that you double the 4 to the 8 at the bottom.
Okay, it turns out that that works, and that will work. What we're interested in doing today is to see if we can understand how we know that 3/4 equals 6/8. So would you look at the picture over here? Tell me, boys and girls, tell me when I have 3/4. Is this box going to be 3/4? Boys and girls, yes or no?
No!
How about these two boxes together? Is that going to be 3/4?
No!
How about these three boxes together? Will that be 3/4?
Everyone says yes.
So on the left, we have 3/4. Now let's look at three boxes on the right. How many 8s are there?
6/8.
6/8. Very good. Okay, let's give our presenter a nice round of appreciation, please, everybody. Okay, so let's try to do this together, boys and girls. 1/4 we said is how many 8s? Who remembers what we said? 1/4 is how many 8s?
2.
What would 2/4 be?
2.
1/4 is 2 8s. How about 2/4?
4.
How about 3/4?
6.
How about 4/4?
8.
8 8s. Okay. Very good. Congratulations. Very nice. Okay. What I want to do now is this. What I want to do now is this. You know, boys and girls, we don't always have to have the yellow block be a hole. You can also have the red block be the hole, and you can have the blue block be the hole. If the blue block is the hole, what's the value of the green block? If B is equal to 1, how much is G?
2/2. Everyone says 2/2.
Okay, let me read the question. If B is 1, what part of B is the green portion?
1/2.
It's going to be 1/2. Okay, if the red is 1, what part of the red will the green portion be if the red is 1?
Okay.
1/3.
If the red is 1, what part of the red is the green portion?
1/2. No,
Is
sorry.
this half of that?
Nope.
No.
How many times does the green go in the red?
How many times?
1/3. 1/3. 1/3.
If the red is 1, how much is the green?
Say it again, 1/3.
1/3.
How many of you agree that if the red is 1, the green is 1/3? Everybody agree?
Yes.
Yes.
Okay, let me change the problem. If the green is 1, how much is the red? If G is equal to 1, how much is R?
This is your whole.
This is 1. How much is this?
Oh.
No, it's bigger. than
2/3.
How many holes would it be?
2/3. 1/2. 2/6.
Put it down there. How many greens does it
Oh,
make a
it's
red?
3 holes. 3 holes. 3 holes. 3 holes.
How many say 3 holes?
How many say 3 holes? Ryan, tell me everybody.
Everybody.
Okay, so if the green is 1 hole, the red is 3 holes. If the green block costs $1 to make, and we forget colors, assuming everything else, the red would cost 3 times as much. So R would be how much?
What?
3. Okay, boys and girls, supposing, okay, this is an honors problem here. Supposing that 2 of the blues is equal to 1.
Okay, this is weird. Make it this
How
way.
much is the green block now? 2 of the blues are 1. How much is the green block? Discuss it with your neighbor, please, before you have an answer. Talk with your neighbor.
Prove it.
A fourth.
If 2 blues is your whole, how much is a green worth?
Fourth. It's
Yeah.
because
4 greens.
it takes
to build it.
it takes 2 to fill up one.
Will you tell Mr. Borenson?
What's the answer?
It takes two green pieces to fill up a blue piece, and you have to double that to have two blue pieces, so it's a fourth.
How many agree that it's a fourth?
Tell everybody.
Everybody.
Wow, very good. Congratulations. Very good. Okay, supposing, let me get a paper here. Oh, you know what? Let me now show you an enrichment lesson, which you'll be doing later, but I wanted to introduce it to you now. This is enrichment lesson 1. You'll get to it much later. So let's look at this one over here. Let's look at the first one. If the blue block is 1, what's the green block? Everybody?
The blue block
is 1.
This is a whole. How much is this? Hello?
Yeah, we are.
Okay, that's exactly right.
Oh.
Blake, would you point in and say 1/2? I don't know if he's waiting for any.
1/2.
1/2. Okay, let me jump down to over here. Let's look at the last one. If 3 red blocks are 1, what fraction is the green block? Please think about it and talk about it with your neighbor.
Build that picture. I want to see you build
Okay.
it. Good. If 3 reds, if that's your whole, how many greens does it take to make that? How much is a green one? We'll figure it out. Prove it. Put the greens on there. I want to see it. That's good. I like it. You're exactly right. Go up and say that answer on the microphone. I know. We'll get a couple more people from the second, third rows up there, but that means a lot. Nice word. I like when you get those light bulb moments. You have to say 1/9, right?
1/9.
How many in the class think it's 1/9?
You agree 1/9?
Everybody.
Are you able to explain how you know it's 1/9?
Because the red pieces, I just put the green pieces on top of them, and I counted by 3s, and I got 9.
Very good. So each one is 1/9. Congratulations. Very nice. Very good.
Thanks.
Okay, Taylor, do the students have, let's give them a hand. Taylor, do the students have any questions for me? Because we're probably going to wrap up in the next few minutes.
Okay, that's great. I'm sure they do. Are they able to ask you about like your work or your job or other things too? Is that okay?
Yes, that's fine.
How many years were you in college?
Well, I was 4 years an undergraduate, and then I have 2 master's degree and 1 doctorate. So I was in college altogether for maybe 10 years.
Very cool. Thank you. Okay, who has another question? Okay, Caroline, you haven't got to talk yet. Come on up. This is Caroline.
Okay, Caroline.
How much do you like your job?
It's my life, so I like it very much. How many of you are using hands-on equations? Are your students using hands-on equations, Taylor?
We haven't in 3rd grade. This year we're doing the fractions instead because we got this opportunity. So this would usually be the time of year where we do hands-on equations. Our 4th grade and 6th grade use hands-on equations currently.
Right. So boys and girls, I developed a way to teach algebra to young kids such as yourself, and more than 1 million students have used the program, so that gives me a great sense of satisfaction.
Very cool. Okay. This is Blake.
Do
Okay.
you have any brothers and sisters?
Yes, we were 6. We're now 5. We're 5 altogether right now. I'm the oldest.
Did you ever play football? Or any other sport?
Oh, I was a gymnast in college. I did gymnastics.
Okay, here's Gabriel has a math question for you.
Okay, good.
What encouraged you to do this math science stuff?
I like doing mathematics. It was always a sense of satisfaction to do it. And when I was a teacher, I noticed that many students had trouble learning algebra. So I wanted to figure out a way to make it easier for them to learn algebra. And so I spent 2 years developing a program called Hands-on Equations, which you may be seeing in your school in the next few years.
Well, Dr. Borenson, thank you so very much. As we keep going, I have notes for you about the stuff we've been doing and things I noticed, so I'll email that to you, and I'll send you a couple pictures of our class working with the developing fraction sense stuff too, okay?
Oh, yeah, that'll be great. So
right.
did you enjoy this session?
Yes, they did. They were very happy with it. Thank you so very much.
Okay, have a wonderful day. Thank you.
Thank you. You too. Bye, Dr. Borenson.
Bye-bye.